mathematical operations on matrices. If we go back to the original or the previous lecture here, we had 3 teams, sporting teams. We could call them Broncos, Cowboys, Titans, and they had in the first 8 games 3 wins, 1 loss. Sorry, 1 draw, 4 losses, and the Cowboys 7 wins, 0 draws and 1 loss, and the Titans had 7 wins, 0 draws and 3 losses. Suppose in the next 12 games after that, each of these respective teams had this number of wins, draws and losses. So this is the first 8 games and this is the next 12. To add matrices, it's important that the dimensions of both matrices are exactly the same. So here, this is a 3 by 3, and this is also a 3 by 3, so indeed we can add them. And all you do is just add the like placed entries. So here we've got an entry in the first row and first column, and we add it to the one over here in the first row and first column. So when we add these 2 matrices together, we add 3 and 10 and we get 13. We add the 1 and the 0 and get 1. And we add the 4 and the 2 and get 6. So this was the first 8 games, this is the next 12. So after the first 20 games, Broncos have got 13 wins, 1 draw and 6 losses. We add these together, we got 6 and 7 is 13, 0 and 1 is 1, and 1 and 5 is 6. So they have exactly the same win, draw and loss. And the Titans had 12, 0 and 0 is 0, and 3 and 5 is 8. Okay, so that's adding matrices. Subtracting, you just do exactly the same except you subtract the individual elements, and I'm not going to go through one of those. But to do subtraction of matrices, once again they have to be of exactly the same dimensions, and you just subtract the individual entries from those. Alright, so that's adding and subtracting. Multiplication by a scalar. Scalar is simply just a number. So that's this sort of scenario. If we have 4, 3, 1, just make up a matrix here, 0, -1 and 5 and 20. This is representing some data, and we're going to multiply by the scalar 4. 4 is simply just multiplied by each of the entries. So 4 3s are 12, doesn't matter which order you do them in as long as you get them all right. 4 3s are 12, 4 1s are 4. So I'll do the top row and then I'll do the second row. 4 0s are 0, 4 -4, and then 20 and then 80. Okay, so that's multiplication by a scalar. Now, multiplication of 2 matrices. Suppose that, and I'll do that by way of an example, do the multiplication of matrices by way of an example. We've got our footy teams up here, so we've got 13, 1 and 6 for the Broncos, 13, 1 and 6, and 12, 0 and 8. Now, this is the number of wins, this is the number of draws, and this is the number of losses. And suppose the points were 2 for a win, 1 for a draw, and 0 points for a loss. Now, if we multiply these 2 matrices, we multiply this number here, it's as though we turn that column sideways and line it up here and multiply the numbers across. So 13 would be multiplied by 2. and then you always add. This number would, if you've got the 13, 1 and 6, it would be 1 times 1. Always plus, and then 6 times 0. Then to get the second row, we turn this one sideways, and we get 13 times 2, because these results here are exactly the same as the line above, it'll be the same, plus 1 times 1, 6 times 0. And then finally this one here, we get this row, turn it there, and we go 12 times 2, always a plus, 0 times 1, plus 8 times 0. And that's not the end of it, because we're required then to evaluate these. So 13 times 2 is 26, plus 1 is 27. And this is also 27. And this will be 24 plus 0 is 24. Now if this was Brisbane, and this is the Broncos, Cowboys and Titans there, this would be the number of points the Broncos were after the first 20 games. This is the number of points the Cowboys have got, and this is the number of points that the Titans have got. So this was 2 points for a win, 1 point for a draw, and 0 point for a loss. What are the dimensions of this one? This is a 3 by 3. What are the dimensions of that matrix? This is how many rows? 3 by 1. Only one column. And this is an important concept when you do multiplication of two matrices. The innermost dimensions must be equal. If they're not equal, you can't multiply them together. Bearing in mind that when we did the multiplication, we got this and laid those numbers, if you like, 13, 1 and 6, so we could just multiply those, add them. If these weren't the same, you would have numbers left over and you wouldn't be able to multiply. So the inner, this is the number, this is rows, columns, and this is rows, columns. So the inner dimensions must be equal. And the outer dimensions here are the dimensions of your answer. What's this here? This is a 3 by 1. What are the outer dimensions here? A 3 by 1. So when you're multiplying matrices together, the innermost dimensions must be the same. If you just put down the dimensions and dimensions, the innermost must be the same, and your answer, the dimensions of the matrix at the end, will be the outer. So just summing up, there's if you had matrix A, which was say a 3 by 5, and matrix B, say was a 2 by 3. Now when we multiply A times B, we've got a 3 times 5 matrix times B, a 2 times 3. Our innermost dimensions are not the same, so this is not possible. We cannot do the multiplication of those two matrices. What about B times A? Now B is a 2 times 3, and A is a 3 times 5, 3 by 5. Our innermost dimensions are the same. So our answer, say, was matrix C, the dimensions of our answer would be a 2 by 5. Okay, so in general, A times B, when we are talking about matrices, is not equal to B times A. because you can get this scenario going on over here. And this is, we say they are not commutative. Commutative is when AB equals BA. So not commutative. Important concept to understand with multiplication of matrices. So what we've covered in this little lecture is adding and subtracting, and they must be the same dimensions for you to add and subtract. So here we've got 2 3 by 3, so yes, you can add, and subtract, you subtract the individual entries. Multiplication by a scalar, scalar being a number, you just multiply each of the entries by that scalar. Multiplication of two matrices, the innermost dimensions have to be the same, and your result or your answer will have a dimension of the outer one, as we've gone through this example here. And then we talked about AB and BA, that when you multiply matrices, order is important. So A times B generally is not equal to B times A. We say is not commutative.